on this computer. All right, it's Monday, May 1st. I'm going to show you a couple of videos of what I expect or what a science fair is, because I realize you guys might never have been to a science fair. So first, I'm going to show you a couple videos of science fairs, just so you know what I'm talking about. So these are just videos of some kids' science fair projects. You can see when you're there in person, they often made these big boards. And if you want to, you can make an online board or you can just present. And you can see they have a catchy title, Gum, Cats React to Music. So I'm going to just show you a few.
As they get ready for their judging this afternoon.
So normally,
I like to watch how things in the fire burn when my dad builds a bonfire for us.
And the title of my project was Celebrating.
The students have been working on their science fair projects since the end of October, so they have put a lot of time and effort into this project, and hopefully they will see all of that come to fruition this afternoon as they compete for first, second, and third place ribbons. First place from both classes will then proceed to go to Ball State to compete. Can come.
So we're not doing it as a big competition.
This is Leverton's class. This was Izzy Wetzel.
Talking to the adults, explaining their project. On sound, there's one on June.
Our next award goes Enthusiastic Science.
So we're going to go away from this one because this one's more about like the competition, and we don't need a competition to do this. We're doing it for fun. So let me go back to my video here if I can get away from my recording. There we go. Yeah, a few science fair presentations. Okay. So here's some more science fair presentations.
Of inches and the results. And then we tried 12 times. And I have the things for, we looked up free fall, velocity, gravity, and
so she's talking about her background research. We're going to be doing that tomorrow, where we study the science behind our chosen project. So today you just have to choose your project and kind of plan your experiment. Tomorrow we're going to do a little research on the science behind your project.
Serrations, and each time I drop the eggs.
The difference it takes to time someone for them to read the word in a different color. The Stroop effect was named after J. Ridley Stroop, who discovered the phenomenon.
Their hypothesis, their materials.
Our hypothesis was, if a volunteer sees a color word in a different color, then it will take them longer to say. As you can see our...
So they're talking about when you read the word red, but it's written in yellow, is it harder to read it? So they timed how long it took for people to read these words. And you can see that they know their project very well. They're able to talk about it. That's what we're going to ask you to be able to do by the end of the week. So today you just had to choose a project and you needed a title. Like this project is called He's got his results, he's got pictures.
The statement of purpose is, I chose to do this project because I liked Legos and I like engineering. I wanted to find out which type of bridge holds the most weight too. I also made a bridge combining the best features from all of the other bridges to make a hybrid bridge, and that bridge held the most. And I think my hybrid bridge would be effective in the real world.
So you can see that these kids have spent a lot of time on this project. They're very prepared. But this is another good one, testing different styles of bridges built out of Legos and then testing to see how much they held. You can see this one held 2 pounds. This one held 24 pounds. Wow, that's amazing. So this kid really knows his project well. He did bridges. We aren't going to make the big cardboard things, but you're welcome to make one if you want to at home. Let's check out this project. The 2-second rule of dropping food on
Touch the ground for 5 seconds or less.
And like what you're talking about, dropping mold.
It is unsafe to eat something that has been on the ground. We also think the longer it is on the ground, the more bacteria it grows. What we used
About the days it took.
3 slices of bologna, 3 swabs, 3 petri dishes with nutrient agar.
So Sasha, the deal here is they had some scientific equipment, so they grew their mold in Petri dishes, and it really did grow in only 4 days. But I don't know if you have Petri dishes.
A stopwatch, a incubator.
It says
They
an
heated
electric
it up
blanket.
to make it grow fast, which is kind of interesting. So this one they checked out, when you drop food on the floor, does it get contaminated? It goes on for a long time. I think that's the last. Oh no, there's one more experiment here. There's another kid talking about whether things.
Let's try this ball first.
Pencil, eraser, marker, scissors. So this is another kid. And
It floats.
it floats.
That's the pencil.
So he studied floating. What floats, what doesn't float, and why. Okay, I think you guys now have sort of an image of what a science fair project is. Did I start my recording? I hope so. Yeah. Okay. So if we go to our project, so again, it's in language arts. You can also get it on the calendar. It's the first module, Flex Science Week. Today you were supposed to go through and pick a project idea. I listed the top 10 of things that kids have done in the past, but you could also choose something else. There are these links at the bottom. This one has 50 projects on it. The next one has another like 50 cool projects. They're all here with all sorts of links and ways to do them. Again, try not to choose something with growing, but you need to have a project by today. If you don't have one by the end of today, tomorrow morning, you'll get an email saying you are doing this project because you did not get your project chosen in time. So if you do not have a project by tomorrow morning, well, by the end of the day today, I'm going to send you an email. Here's 70 more easy experiments that you can do. Ooh, that's a cool one with Skittles. There's tons of neat projects. Your job today was to look into these websites, choose a project, and decide what you're doing. After you did that, if you go back to our subject and you look in the module, the one assignment after Science Fair project ideas is called My Science Google Doc. And what it is a document with all of the things you need to do. So it says, click here to make a copy of that. You need to click on that. And you need to make a copy of your Science Fair project. So you click right there and it will open up and then you'll have a copy. You need to label it. Oh, here's Amadi's right here. I wanted to find mine though. Where's mine? Here it is, Ms. Laws. I'm going to title mine The Fastest Flight. I better capitalize that because lately some kids have been forgetting about capitalization and it's important. So this is my title. Titles are always capitalized. I'm going to capitalize it. I might even make it bold and a little bigger because it's my title. Fastest Flight. Hypothesis. I believe that the airplane with the biggest wing surface area will go the farthest. What you want to put here is what you're trying to show. If you're doing a model of a rocket, you might say, I think that if I follow the directions carefully and build my rocket properly, it will fly well. I believe a rocket that's longer flies higher or something like that. Eli, what's your question?
Can I have help with this question?
Well, I'm doing it right now. So you need a title and you need a hypothesis. So which experiment are you doing, Eli?
Airplane.
Okay, so what is it you think about the airplane? What do you think will make the airplane fly better?
If it's smaller.
Okay, so then you need to write, I believe that the smallest airplane, are you going to use the same size paper though, but just fold it smaller? You need to have everything the same except for the design. So if you're going to make it smaller, it needs to be the same amount of paper, just fold it in half or something.
Yeah, I know.
Okay, so write that down. I believe.
I did that already. I'm already on the.
Oh, okay.
Probably...
We're gonna keep going. And when I'm all done, if you still have questions, ask me. So you write down what you believe right now. Hopefully you have this open and you're working on it. You need your name up here, name here. You need to have shared it with me. And now you're filling it in. I believe that the airplane with the biggest wing surface will go the furthest. So now ask yourself, why? Why do you think this is true? What is it you know about science that makes you believe that? I think this will happen because a bigger surface area, the plane will be able to fly further. I think the air under and over the wings will help lift it up. Planes have pretty big wings. Oops, big wings. So I think that's important. And kites have big surface area too. So here you're just saying all the things you know about science and why you believe what you believe. So it's not like a right or wrong answer. It's just why you think this is going to happen. All right, design your experiment or explain what you'll do. And you can make this smaller now if you want to shorten it up. If you want to get rid of the spaces, you can change this. I will isolate the variable, the shape of the airplane is what I'm isolating. That's my variable. I will use the same size paper and throw it the same, but just change how I fold the paper. Here's what I'm going to test or do. I'm going to research some different winning airplane designs and fold my paper into 3 designs. Then I will stand at the same place on the same day, because I think I'm going to have to do it outside and I don't want it to be a windy day one day and another one, and throw each plane 3 times, recording the distance in, I don't know, feet. I guess I'll use feet. So here's what I will measure with. I'm going to use a yardstick. I will use maybe a tape measure. That's what I'm going to use because it's longer. Because, oops, it is longer, and use feet and inches to measure the length of the row. Now, if you're doing like the gum experiment of how long the flavor lasts, then what you're using is a stopwatch and time to measure, right? We know that you can measure time, you can measure distance, you can measure weight, you can measure temperature. So you need to think about with yours what you're measuring. Now, if you're building a rocket design like Liam is, you might be measuring how far the rocket goes. I don't know, I'm trying to think of some other ones. How much mold you might be creating. One thing here that you sometimes have to do is create a rubric. You might, I'm just going to write this down, need an observational rubric. So for example, if you were testing to see how brown an apple gets or how much it gets dried out, you might go like this. 1, no equals no change. And what you're doing is adding numbers to help judge it. 2 equals slight color change. 3 equals dried up appearance. 4 equals both color and dried appearance. So if you're thinking of an apple drying up or something like that. 5 might equal moldy, smelly with dark brown and shriveled. So what this is a rubric. It's a way to judge something. Since you can't judge it in inches or weight, you have to invent a way to judge it by giving numbers to what you see. So your project might need an observational rubric. Mine doesn't, because I'm measuring distance. Does anybody think they have a project that's going to need a different way to measure it or not know how they're going to measure their project? Javen, Hunter, Amoy, Lise, you know what project you're doing and how you're going to measure it?
I know which project I'm gonna do, but I don't know how to measure it.
Well, what is your project?
It is the dry ice bubble.
And what is it you're trying to measure? How big it blows up? How large it gets? Or are you measuring how much dry ice you put in?
Oh, I can measure how much dry ice I put in.
So you're going to want to measure both how much dry ice you put in and how big the bubble gets, right?
Okay.
So you're probably going to need a rubric like this, where like number 1 might equal no change in the bubble. What's it blowing up? A balloon or making a bubble?
Making a bubble with soap.
I've done those soap bubbles. They're super fun with the dry ice. So if there's no change or no bubble, right? It doesn't work, no bubble. And then you could do like tiny bubble, medium-sized bubble, and large bubbles. Large bubbles, or you could do how many bubbles, right? Because I don't know exactly how your thing's going to bubble, but you're going to need a rubric like this to measure it, Javen. Is there anybody else who thinks they need a way to measure it? I'll leave these on here. I'll make it small and leave them on in case we need to look at them again. All right, now list the materials needed. For mine, I'm going to need 3 pieces of paper. I'm going to need a chart to record my data. I'm going to need a measuring tape. I think that's all I need. I throw it, I measure it, I record it, right? That's it. Okay, that's all I need. So I can move this up. And I'm to the steps. First, research different styles of airplane, of paper airplanes that go far. Then build or fold, fold my 3 planes. 3, make a chart to record distances for 3 trials. 4, do the, let's see, row the planes each 3 times, recording how far they go each time. 5, throw the planes 3 times, recording how far they go each time. 5, I don't know what 5 is. I guess I'm done then. I guess write down which plane went furthest and tell why you think it did. Was your hypothesis right? Okay, so those are my steps. I wrote 5 steps. Yours doesn't have to have 5 steps. It might have 20 steps. It might have 2 steps. Tomorrow we'll design a chart and do our background research. So I am done with this for today. Of course, I need to remember that I've got to go to the assignment, go to the next one, and it says day 1, and I need to make sure that I have submitted this. So on day 1, I want to submit something that either says, right here, text. Either is a link to it with the web URL, so I could open it up again. I could copy the link right here. Oh, that's not even it. Where's my copy? Here it is. Oh, that's Amadi. Here I am. Okay, I could go to share. I could get a link. If I could, private only to me. I need to make sure it's not restricted. Anyone with a link, copy link, done. Now go back to this, go in here, web URL, and put in my link, right? And I'm done. Submit assignment. Yay. Okay. I could also submit text saying that I shared it with me. I shared it with me. I shared it with you, Ms. Laws. Okay. Oops, I forgot to reset, leave student view. So that's really all there is to today. Today you're choosing a project. Right now I have a project for Amadi, Liam, Nora, Evie, and Megan. So if you're here and I did not say your name, I want you to tell me your project before you leave, okay? If you need to go look at that list of projects, you can go to a breakout room and do that. I'm going to close.
I told you my project though.
Okay, so what is your project again? Tell me again, Javen.
My project is the dry ice bubble.
Okay, but you still need to share something with me because like on your paper that you wrote with Eli, he submitted, but you did not. So you still have to go to the assignment, day 1. It's one assignment you have to submit today and say, Ms. Laws, I shared my Google Doc with you, or give me a link to it, okay? Eli, what are you thinking? What are you going to do? Airplanes?
I already submitted my thing.
Are you doing airplanes?
Yeah, I'm doing the airplane.
Okay. Javen, Eli, who else? Amadi, I know yours. You're doing melting chocolate. Brianna, what are you going to do? Do you know yet?
No, I don't know yet.
Okay, so click on that link. Let's just stay with me. Click on that link and go look at all the project ideas. And if you don't decide on one, I'm going to assign something to you, okay? Probably going to assign the paper airplanes just because it's easy. Amoy, what are you thinking? You told me you were going to do the balls, and then what did you decide? The paper airplanes?
Yeah, the paper airplane.
Okay, perfect. Airplanes. So make sure you go fill out that form. Luis, what are you thinking? You can answer in chat if you don't want to talk, buddy.
What do I do right now?
Well, so Amadi, you can go research chocolate, how it's made and how it dissolves. There's quite a bit of, I would type in like the science behind chocolate and melting chocolate. Okay.
All right.
There's quite a bit of science behind it. And make sure that you've checked with your parents about the zoo tickets. Amadi, have you done that?
They said no.
They said no zoo for you? Wow.
Nope. I mean, we already have membership for the zoo, so I can kind of go anytime.
Oh, that's true. That's true. Okay. All right, my friend. All right, then you can take off and just go study the science behind chocolate. Javen, you can go study the science behind yours and make sure you fill out that form and turn it in. Amor, you can study the science behind airplanes.
Wait, I can leave.
Mm-hmm.
Okay.
Salome and Luis, I'd like to know what your projects are. Do you know what you're going to do? You can put it in chat when you know. Luis, if you don't know, I really recommend you do something like the 3 different styles of paper airplanes or one of those top 10 projects.
Bye.
Bye. Brianna, Luis, and Halame, I need your projects.
Wait, do we have book clubs today?
You do at 2:30, so in 6 minutes. Why don't you stay then? Who else is in your book club? Did I just send them away?
Yeah, I think Liam was in my...
Yeah, but Liam didn't come this afternoon yet, so I think he's probably working on his project. He's excited about building his rocket. So the book club, I'll open it up and you can go there and wait, okay?
All right.